first thing we're going to do is our Bohr model. So we're going to do fluorine. And so fluorine has 9 protons, as you can see up here. And then, so 9 protons. And then you subtract the number of protons to the atomic mass number. So then if you subtract that, then it's 10, and that's how many neutrons they are. And the protons are the same amount of number as electrons, so we're going to put 2 electrons in the first shell, and then in the next shell, we are going to put 7. So we're going to start here, put 1, 2, 3, 4, 5, 6, 7, and then there's 1 left over. Sodium. Oh yeah, so next we're going to do sodium, which is, sorry, gotta look at this, Na. Oh wait, why did I just say that? Can we cut this?
Yeah, okay, trim that.
Okay. So next we're going to do sodium, which is 11 protons. Oh gosh.
Oh no.
Yikes. This is going really well. Okay. 11 protons. And then if you subtract 11 from 23, that's 12. So there's 12 neutrons. And then the same amount of protons as electrons. So we're going to start with 2. And then we're going to make our other shell. And we're going to do 8 in the shell. 3, 4, 5, 6, 7, 8. And then we have 1 left over, so we're going to put our 1 up here. And then we're going to, what is it called?
Ions.
Ions. So we're going to put our missing ion, and we're going to put it here. And then that is -1, because we're minusing protons. No,
Which one?
I don't even know. It's just
Electrons.
electrons. We're minusing them, which makes sense. And yeah.
Let's go.
Okay, we're gonna do chemical names and their compound for ionic compounds. So we're gonna start with multivalent metals. So it's copper, Roman numeral. Roman numeral 2, and zinc. So how we know it's a multivalent metal is because it has the Roman numeral right there. So we're gonna find copper on here, and see how it's +1 and +2. So now we know it's +1. So we're gonna write it like this. So we're gonna go Cu, and then we're gonna do zinc, which is Zn, and then we're gonna do a 2 down here. Why we don't do a 2 for the copper is because zinc is already +2, so we don't need to put it in there because then people know it's 2. Next we're going to do binary compounds, which is just two compounds put together that are non-metal and metal. So we're going to do oxygen, which is O, and then we're going to find silver, which is Ag, and then we're going to do Ag. So then we're going to put a 2 here because oxygen has a +2 and we have to cross it over, but then Ag has no what's called plus, so it has a -2, and that has a plus, so we don't need to put it in. It's going to be the worst video ever.
The next one.
Okay, and the next one is compounds with polyatomic ions. And we're
Damn it, Callie. Polyatomic.
Polyatomic. Okay. Compounds. Next one we're going to do is compounds with polyatomic ions. And how you know it's polyatomic, because it either has an I or an 8 at the end right here. So it has an 8, so it's not on the sheet, so we're going to turn it to our polyatomic table. And we're going to find nitrate, which is right here. So we're going to write NO and then a little 3, and we're going to put that in a bracket. And then we're going to write a 2 here because we know oxide is 2 charge, and so it's an O because that's the oxide symbol. And then this doesn't have any charge because you can see like you can see the other, like sulfate has a +2, so it doesn't have any charge.
We name acids with this flowchart. So, for example, if a formula contains if it doesn't contain oxygen, then you go down here, and then if it contains the "ide" ion, for example, hydrogen chloride, then you change it to hydrochloric acid. If it does contain oxygen and it contains an 8 ion, for example, hydrogen nitrate, then you change it into nitric acid. If it contains oxygen and it contains an 8 ion, for example, hydrogen sulfite, you change it to sulfurous acid.
So we're going to do the Lewis diagram, and we're going to do sulfur. So how we know there's 6 on the outer shell that are left over is you go 1, 2, and then you skip these ones, and you do 3, 4, 5, 6. So then sulfur's at the 6. So there's 6 on the outer shell. So we do 1, 2, 3, 4, 5, 6. So there's 6 left over, and that's how you do it. You just do the outer shell. And yeah. So now we're going to add magnesium. And since it's in this, what is this called?
Magnesium?
No, what is it, like combining them called?
Compounds?
Compounds. Okay, so we're going to combine the compounds. So we're going to do magnesium. So in magnesium, it's the second one, so we're going to do 2 leftover ones, so like this. And then since this is missing 2, we're going to do this. So magnesium, this, and then we're going to do sulfur, and we're going to add the 2 from here, so we're going to do our S again, and then we're going to do an 8, so it's a full outer shell, and then we're going to do -2 because we minused 2 from here.
The pH scale helps determine the acidity of an acid. This graph helps us determine the pH level by, for example, if you test a chemical with each of these reactors, then you can find out where it lands on this graph, and yeah.
Are you filming? We're going to do covalent compound. So how you know it's a covalent compound is because they're both non-metal. So nitrogen is a non-metal and sulfide is a non-metal. So then we're going to do nitrogen because sulfide is 2. So we're going to do di. So di-nitrogen. And since nitrogen is -3, we're going to do trisulfide. And that's how you do covalent compound prefixes. Okay. Will we just okay. A compound is a non-metal and a metal, 2 elements that have the same ionic charge. So oxygen and zinc, they have the same ionic charge, and they're a non-metal and a metal. That's it.